Testing. Now, hi everyone. Today, I would like to talk of the last places where you can get some useful materials, and that is rocks and material and minerals. So, which echoes with the previous chapter. For chapter 2, we have got atmosphere. So mainly we will get something like a gas. So we may get it like nitrogen gas, oxygen gas, argon, etc. So chapter 3 we have got ocean. So we have got some raw materials just like water, common salt. While common salt, what we will call it in detail, we will call it as sodium chloride mainly. Okay, so this is what I would like to see it in gas, in liquid. And how about chapter 4? Chapter 4, we try to get some raw materials in solid. So we will tell in the planet Earth, all those they are what we call it as rocks. And inside that we have got something like minerals. So rocks, 岩石, and minerals we call it common. Okay, so today we would like to talk to you something more about what can be found in the inside rocks. And indeed, about 25% of the Earth crust consists of metals. So, however, such as metals such as solid and silver exist as free elements of the Earth. Most of them exist as compounds in nature. So, what is the hidden meaning? You go to the ground and you dig it under the ground, and you may find most of them they are just very dull solid, okay, but not shiny, but not silvery. So the dull solid they are mostly in what we call it as a compound. So what is that? They're mainly as metal compound, and which gives a dull color. And for gold and silver, yes, of course, we can get the gold ore and silver ore. However, you may find that it's quite rare, and once you dig it, and only a certain type of metal like these two, they will give you a shiny appearance, telling you it's metals. So, the individual chemical compounds that made up of rocks, we call them minerals. So, for those places or for those rocks that we may find the metals, we call it ores. So you may find the ores they have of different colors. Some of them they are white or orange, and some of them we find is yellow, reddish brown, okay, or maybe something like white. So it is what we will say it, and the color of the rocks they will give you different colors, and in this some metals they are found inside. Don't get too worried too much about memorizing the color of the ores and the metal to be responsible. It is out of a syllabus in Form 3, so if you want to know more about this, you may choose chemistry in Form 4. Now, you may take a further look on the way to extract the metals. And once again, once I see it as extraction, which means that yeah, in Form 3, we seldom ask you those content inside, so don't worry too much. And starting from metal from ore is called extraction, extracting the metals. So they are mainly two big methods. One is physical method, one is chemical method. Remember, for physical method, we do not have any chemical change inside. We do not have any chemical change. So what we call it as a physical method, just like gold, you dig in the ground and you discover some shiny, you just pick it up. Or in the past, you may see that how will you get the get the gold? We use the technique what we call it as panning, 淘金, panning, 淘金. So what is that? How is it like? So you may find it easily in the past. You will find it easily in the past. So you may find some photos inside. So this is what we call it as 淘金. So the people in the river they will have a sieve, and they try to get some solid and mainly soil and mud here, and then wash it, and try to see if they can find something silvery. Okay, so this is what the whole process in which you just see it and pick it out from those solid and no chemical change will be occurred. So we will call this type of method panning. It is a physical method. Okay, so this is one way. Now, how about the other way? So you may see in the in the book chapter 4 as well. And for the chemical method, there are quite a few methods, such like heating the ore alone, just directly heating, and you can turn some metal back to metals. Just some of them. For example, mercury, what they call it in Chinese, we call it 水银. So it is from cinnabar. Cinnabar is something like red powder. In Asian Chinese, where we'll use it, we call that 學頂紅. So a very traditional so-called medicine, which claimed by the Taoists in the past that you eat it, to make some medicine board first of all, and ask the emperor to eat it, and it will make the emperor live long. Of course, nowadays you find that it doesn't make sense because mercury is toxic and it will affect your nervous system. And how about sulfur? Sulfur can be found in the ore. One of the very from sulfur ore. So sulfur oxide is something gray, and I heat it for some time. They will form something sulfury. We call it sulfur. Second, you may find the heating ore. Besides, you may for some metal just like iron. Okay, you may heat it with carbon in a blast furnace, 鼓風爐. So you may get it for iron oxide, and I've got carbon. I heat it. It seems like the carbon is taking away those oxygen inside to get carbon dioxide and leaving iron left behind. This is another way to extract the metal. So I would like to show you what is 鼓風爐 blast furnace. Blast furnace. A very big machine. Okay, so you may get the iron inside, and finally they will come up like this. So we have got a very, very tall tower like this, and I put the carbon monoxide and carbon here to have a further reactions with the iron 3 oxides, the iron ore. So finally, the orange liquid that's come out, it's molten iron. And what's next? You may find it. What's more is about this one. It is more vigorous method. We call that electrolysis. 電解 again. Yes, that's right. But the 電解 electrolysis of what? This time I put the molten ore. Molten means I melt the solid ore to liquid. So you may see the technique will be more advanced. Now, normally speaking, if I take this one example, you have to raise the temperature more than 1000 degrees, such that this aluminum oxide can be turned to liquid. And I do electrolysis, and they will turn back to aluminum and oxygen respectively. So I just name a few. Or we have got different methods to extract the metals. But don't worry too much about page 32. This will not be examined in your exam. Now, around those metal ores, I would like to introduce one in which people from past to present, they will use it very often. That is one of them. It is calcium compound. It's a calcium compound. What we call it as calcium carbonate. Calcium carbonate. Chinese, I would like to write the Chinese here. We call that 碳酸鈣. 碳酸鈣. So having the formula, if you want to get to know more about that, we call that CaCO3. So what is that CaCO3? Of course, we got calcium, we've got carbon, and Nate. What is that? It is oxygen. Calcium, carbon, and oxygen, a compound made up of that 3 elements. If you go to the nature, they exist in 3 main forms. The first one, we call it chalk, 白蟻. Second is limestone, 石灰石. And the third one, you may find in marble, 大理石, or you call it 雲石 in Chinese. So they all contain the same mineral. We call it calcite, 礦方解石. So you may see it on the right hand side. You may see this one, a colorless, transparent solid, the calcite. But if you want to talk about chalk, limestone, and marble, because they are of different forms, they are in white solid. Okay, but don't worry, we would like to talk more about that white solid. First of all, how would you get quite a lot of those white solid, the calcium compound? It is mainly from the nature of animals, okay? Because sea animals, they have got the seashells, they have got the skeleton, so that too contains calcium carbonate. So what is this mean by the sea animals without shells, such like seashells of clams? Okay, for example, for those with Chinese, we call it 貝殼. So and even the skeleton inside contains calcium carbonate. Once those animals die, their skeleton or shells, they will sink in the mud at the bottom of the oceans. Over the millions of years, could you please underline the conditions of making? First of all, long time, millions of years. Second, or we'll talk about the layers that will build up, and you need to apply the pressure, and they will push those materials downward and downward and downward, and finally they will form chalk first of all. Okay, so this is what I would like to talk to you. So if I apply higher pressure and heat, they will cause the chalk to turn to much harder limestone, and then the limestone, if they undergo even higher temperature and pressure, they will turn to marble. So you may find those three, chalk, limestone, and marble, we talk about the same chemical, calcium carbonate, but the way to form is different. Chalk is formed earlier, but it is soft. Okay, but if you want to talk about marble, okay, it is hard. Okay, they will form later. So limestone is just in between. So how can we change from chalk to limestone back to marble? Is we need time, heat, and pressure. You need to take a long time, such that you can go from chalk to limestone, from limestone to marble. Okay, so no matter you talk about chalk, limestone, and marble, all those three materials, they are very important in building industry because they are inexpensive. Inexpensive means very cheap. It doesn't cost any money or too much money actually. So your marble is a crystalline solid, it's very hard. So especially this one is a little bit more expensive. If you can polish smoothly, they will give you a beautiful experience. So that's why you may see marble being a building structure, 雕塑, and monuments as floors and walls in some buildings. So well, because once you know it in Chinese, we call it 雲石. You may find that you may be in floor, you may be a building, you may be a structure, etc. You may get this. What are the uses of limestone actually? Limestone is used as a building materials. So you may use to construct building and roads. So many other uses, just like making footpath, the making cement, and it is raw materials, and even this one can be used to neutralize the water or the soil which is acidic, maybe it's affected by acid rain. So you may decrease the acidity of those water and soil. So this is what I would like to talk to you about this part. And 4.4, you may talk about more about that rocks. For some instance, you may see some very strange shape of rocks. The rocks of very strange shape. You may find it like this way. You may find it like this way, or all those rocks. Once it is exposed to air, they will undergo a chemical change. We call that a weathering. 風化作用. So if you talk about the chemical change, we'll talk a bit the rocks, they will undergo erosion, 侵蝕. So I would not like to talk too much about something about geography here. Instead, I would like to talk to you something more about chemistry. Have you ever seen something like this? Okay, I would like to show you here. Here. Have you ever shown something like this? For example, limestone caves. Have you ever seen that? Limestone caves. What is that? In Hong Kong, we do not have it, but we will have some places in the world. You may have some underground water, for example, and we have got some caves inside with very strange or rocks. It seems like the solid tears, they just hang it from the ceiling, and they will have some water that drop underground. So the water that will form here. Okay, but at the same time, you may see those type of the stone pillars. It's not just from the top to the bottom, but also here. Okay, like this. Okay, those stones, they are actually calcium carbonate, while the caves here, we will call it as the limestone caves. So today, I would like to talk to you more about those substances, like those calcium, as well as what we find it is underground water. What can be found inside in the underground water here? Okay, you may see it in blue, so you may find that. Okay, of course, it's not blue actually, it's because of the effect of the light. The real water here, what we call it as mineral water, mineral 礦泉水. So this part, it is, I use the blue light to shine it. So what is being found inside the mineral water? Well, there will be something chemistry behind. How come those rocks will be eroded by chemical waste? It is because of rainwater. Now, rainwater, if you go back to Form 2IS, you talk about rainwater is slightly acidic because of pH, where you may find it about 5.6, is because of the dissolution of carbon dioxide in water. Okay, carbon dioxide in water, they will form an acid, we call it carbonic acid, 碳酸, carbonic acid, 碳酸. So 碳酸, carbonic acid, can also be found in some soft drinks, for example. Okay, if you have got the fizzy feeling, where those bubbles inside, it is indeed carbon dioxide. Okay, while the acid, we talk about it as carbonic acid. Indeed, calcium carbonate is not soluble in water, but when these carbon acid, they touches the limestone, they would react to form something which can dissolve in water, soluble. We call that calcium hydrogen carbonate. Calcium hydrogen carbonate, we call that 碳酸氫鈣. 碳酸氫鈣. So this one, I would like to represent the formula like this, but I would like to introduce to you what is that. It will call as S, AQ and AQ. AQ means aqueous solution, now, which means that it is water soluble. Water soluble, it can dissolve in water, and that two reacts, the carbonic acid reacts with calcium carbonate to form calcium hydrogen carbonate. But this type of reaction, it takes a very long time, so very long-term process. But that reaction, they will lead to the formation of caves for many years later. Okay, so that's why we've got those limestone caves. So once you go to talk about spring water or underground water, what is that? So it is full of mineral, okay, full of calcium. Or for some instance, you may get some magnesium as well, magnesium ions as well. So altogether, those water, they are full of such minerals. We call that mineral water, 礦泉水. So that's why it is quite different from distilled water. Okay, because distilled water is free from the mineral water. It's 100% water, no mineral inside. But if you talk about mineral water, we may have that calcium and magnesium, iron inside. So this is what we talk about the first pages. Shall we take a look at the checkpoint? Limestone is mainly composed of calcium carbonate. When exposed to correct conditions over many years, limestone changed to marble. Give one use of limestone in industry. Can you think of some examples? Yes, some of you may think it as I've just said before, it can be used as a construction materials to act as construction materials. Okay, so for example, to make cement is also one of the building materials, or to make glass, etc. So this is you may think of so many different ways in industry, right? So what conditions causes limestone to become marble? Now, this one you take longer time to form this. So I need one more thing. What is that? High pressure and high temperature, heat. Okay, what I want to tell you is heat. So and they will turn limestone to form harder marble. And C, state the difference in the hardness of the marble when compared with limestone. As I said before, marble is harder than limestone. Okay, is that clear? So this is what I would like to talk about that one, question one. Question two, calcium carbonate, calcium carbon dioxide, carbon dioxide is slightly soluble in water. When it dissolves in water, the solution formed is called carbonated water. Write a word equation that shows the formation of carbonated water. Its chemical name is called carboxyl. So what is that? Indeed, it tells you why there is the carbon dioxide is what we call it as an acidic gas. It's because of this reaction. So I expect you guys who can memorize this one. Now you may see in the book, you may find such, right? Do we need to write it down here? The answer is no, you need not. Okay, you need not write it down in form 3. So if you want to have such a chance to write it down like this, you may get promoted to form 4 and choose chemistry, and you may know how to write it down like this. And word equation is an equation to tell you express the chemicals in words. And this one, what is that? We call that a type of chemical equation. So the two of them, you talk about the same thing, but the way to present is different. Now, B, state the long-term effect of carbonated water of limestone. State the long-term effect. So we are going to write the word equation to show any chemical changes, chemical equations involved. Now, first of all, what is limestone? Yes, you need to go back to chemistry, right? Limestone, it is made up of calcium carbonate. Okay, first point. And second, what is the long-term effect of carbonated water of limestone? So carbonated water, it is indeed carbonic acid, as said before in part A. So we write down carbonic acid reacts. There is a chemical change with calcium carbonate slowly, because I talk about long-term effect. It's a very, very slow reaction to form what? Water soluble calcium, a very long word, hydrogen carbonate. Now, so remember, for word hydrogen carbonate is one word. Hydrogen carbonate is one word, but not two words. And then, and which can be drained away, or you use the word washed away by water. So you just having that 2 point, 1 point, 2 point. And what is mean by the word equation? You need to write down something like this with an arrow. So what is that equation? It seems that Mr. Chin, you want to tell me that you are going to memorize it. Yes, you have to memorize. And this will be also be examined in the exam. So you may find it, carbonate reacts with calcium carbonate to form calcium hydrogen carbonate. So a very long term. This one is water soluble. This one is not. And that is the reaction between carbonic and calcium carbonate slowly to form something water soluble, calcium hydrogen carbonate. Okay, so this is what I would like to talk to you about 4.4. Now, shall we maybe stop for a while and you take a look more about calcium carbonate? So, what is calcium carbonate? We need to do further investigation. So, I would like to show you a video now to let you know more about that. What is meant by the calcium carbonate?
In this experiment, we are going to investigate the actions of heat, water and acids on calcium carbonate. First, add 3 spatula measures of calcium carbonate powder to a boiling tube. Hold the boiling tube with a test tube holder. Heat the boiling tube strongly in a non-luminous Bunsen flame for 15 minutes. And swirl the boiling tube from time to time over the tip of the fire. Allow the solid to cool down for 5 minutes. Put all the solid into a beaker. Half fill the beaker with water and stir the mixture for about 10 seconds. Filter about 15 cubic centimeters of the solution into a boiling tube. Pump carbon dioxide into the filtrate through a straw. What do you observe? Add 1 spatula measure of anhydrous calcium carbonate powder to a test tube. Fill the test tube with water to 1/3 full. Stopper the tube and shake. What do you observe? Is calcium carbonate soluble in water? Fill a test tube with dilute hydrochloric acid to a depth of 2 centimeters. Add 2 spatula measures of solid anhydrous calcium carbonate to the acid. Quickly stopper the tube with a rubber stopper carrying a delivery tube. Pass any gas evolved through lime water. What can you observe in the tube containing calcium carbonate and dilute acid? What can you observe in the test tube containing lime water?
So what do you think? What do you think? Well, you may find calcium carbonate we have got three actions of that mentioned in the video. The first one is action on heat, a very long process, and the second one, action of water, and three, the action of axis, right? So you may find that three. Now, I would like to talk to you about the second one because it's very short. Once I mix with water, what will we observe? You may find that or seems the white powder still it is suspended inside solution, and it seems the powder does not dissolve in water, so it is not soluble in water. So first of all, it just want to tell you one of the very important uh, properties of calcium carbonate. It is insoluble in water. Okay, and second, if you talk about acid, it reacts, right? It reacts. But how about the heating of it? It also reacts. We have got some chemical change, but not obvious. But not obvious, because you may see the white powder still being white powder, right? So I would like, but indeed, some chemical changes have occurred. So I would like to talk to you what happened inside. And first of all, you may find calcium carbonate. I use limestone for example. It is warm with a Bunsen flame, and what will happen if undergo strong heating? Now, the strong heating we will call that rolling Bunsen flame. You heat the calcium carbonate for long, and finally, what will happen? Now, in this, some gases has been come out, so it is CO2, carbon dioxide. So the calcium carbonate undergoes strong heating to form carbon dioxide. Both solid, they are of white powder, but they are different. Before the reaction, we call it calcium carbonate, 碳酸鈣. While, but you talk about after heating, the white solid has been turned to another new chemical. We call that calcium oxide, 氧化鈣. Calcium oxide, 氧化鈣. And we have got a common name, 生石灰, quicklime, quicklime. Anyone who have heard of the word quicklime? 生石灰. Yes, that's right. For those people who just watch some TV drama series, right, in the past, for those Chinese people, right, you just fight together. You want to make a trap on the people. They will have that, right? We have got the white powder that sprinkle to your eye, and your eye will get hurt, right? So what is that? That white powder, what they call it is quicklime. How will you know? Now, very often your eyes has been got hurt by the white powder. Those people they will yell, right? They will yell, "Oh, so painful, so painful." So what will happen next? What will happen next? The people, they will ask you to not to use water to wash your eyes, right? It's quite different from in the past while in the laboratory, right? Because whenever I have got chemicals that spill in your eyes, you have to wash with water. But once I the lime's quick lime come to your eye, you never wash it with water. Instead, do you still remember what do the and other people who say, right? They will say that don't use water to wash your eyes. Please use vegetable oils to wash your eyes. Why? And indeed, instead, do you want to tell me that quicklime will react with water? Yes, that's right. Now, quicklime will react with water. Quicklime will react with water to form slick lime. Slick lime 熟石灰. So, if you want to talk about chemistry, it is a reaction between calcium oxide and water. Okay, so 熟石灰 that will be formed calcium hydroxide. Calcium hydroxide. In Chinese, we call it 氫氧化鈣. Now, but what is the difference between that? From the appearance, is quite is quite difficult for you to distinguish because no matter you talk about calcium carbonate, calcium oxide, and also calcium hydroxide, all three solids, they are white. They are white in color. So it's quite different to it will make it difficult to distinguish. However, if I want to add further addition of water, okay, to the calcium hydroxide. Finally, they will form some white suspension, 圓軸液. Some milky solution is formed. And later on, and why is it like that? Because calcium hydroxide is only slightly soluble in water. So those white powders still remain undissolved. If you filter the suspension, you may get the clear solution again. That clear solution, it is indeed lime water. How will you know it is lime water? You may recall your memory about the video. What happens to the people? They will have a straw. They will bubble the carbon dioxide into it. So I bubble carbon dioxide into it. What will happen? It will turn lime water milky. So that's why I would tell you those colorless liquid, it is lime water. Okay, so what happened to why will we turn lime water milky? Actually, it's a chemical change. A calcium hydroxide solution, it is in lime water now. I bubble carbon dioxide to it. Okay, so they will turn lime water from colors to milky because something, it is water insoluble, has been formed. So you may find calcium carbonate again. Okay, calcium carbonate again. So this is not soluble in water. So you may find this equation. Please memorize this one. Calcium hydroxide plus carbon dioxide to form calcium carbonate plus water. Now, indeed, you need to memorize these two equations as well. Calcium carbonate, strong heat to form calcium oxide plus carbon dioxide. Second, calcium oxide plus water to form calcium hydroxide. 3. Calcium hydroxide reacts with carbon dioxide to form calcium carbonate plus water. Would there be any more reactions? Yes, that's right. Now, this is something more complicated. So when I bubble the lime water for a longer time, into lime water a longer time, you may see the white precipitate disappear. Why? Because the precipitate dissolves to form soluble calcium hydrogen carbonate. So what is the chemical change? It is calcium carbonate react with carbon dioxide plus water to form calcium hydrogen carbonate. Oh, something new equation, right? But if you memorize those equation one by one, you may find that this equation is very similar to the previous equation I just introduced. What is that? Yes, that's right. So calcium carbonate, indeed, I discovered that one equation very similar is this one, right? The limestone, they will be eroded by the rainwater, right? Calcium carbonate react with carbonic acid to form calcium carbonate. What I want to show you is on this equation, right? Calcium carbonate, carbonic acid, calcium hydrogen carbonate. And this part, how about this? It's very similar. Calcium carbonate, these two merge together for carbonic acid to form calcium hydrogen carbonate. What we talk about it is the same. So you may find it into the observation is that lime water originally is clear. I bubble the carbon dioxide to it, they will form milky solution because of calcium carbonate being insoluble in water has been formed. And later on, I bubble into excess 過量 carbon dioxide gas into it, the solution becomes clear because this one is calcium hydrogen carbonate. Okay, so it's no longer lime water, it's calcium hydrogen carbonate. It is water soluble. So do you mean that, Mr. Chin, or you want to introduce this to me? Yes, that's right. What is that? We call that limestone cycle. Cycle, which means a circle, right? Which tells you the limestone can be regenerated. So the first of all, limestone will first of all under heating, they will turn to quicklime, calcium oxide, and then quicklime, calcium oxide. If I add little water, to form slick lime oxide, which is calcium hydroxide. If I further add more water and then stir it well and then filter the solution, I get the filtrate. 類型. So as lime water, okay, so as lime water. So indeed, what is that? It is calcium hydroxide solution. If I want to add carbon dioxide into it, into the lime water, finally, calcium carbonate will be regenerated, will be formed again. Because something milky has been formed, something what it is not soluble. The white powder, which is not soluble in water, it is calcium carbonate. So remember that limestone cycle, right? This is commonly assessed in your public exam. Okay, so this is what I would like to remind all of you here. So shall we take a look on the next page? Okay, so if you say so, Mr. Chin, wow, you have got a very long pathway of calcium carbonate. Yes, that's right, you need to memorize that. But don't worry, you may spend some time on it. You have to spend some time on it and try to figure out which what is that actually. So what's next? We are going to take a look on the final point, which is the test for calcium carbonate in the sample. How will you know that? Suppose you are given some samples. How will you know that you have got calcium carbonate? So it's very similar to the previous chapter. This is a compound, right? Try to split it into two parts. Calcium, something positive. Carbonate is something negative. Okay, and I would like to show you the formula. Calcium carbonate, what is that? It is CaCO3, right? Ca, calcium, calcium ion Ca2 plus, and carbonate is CO3 2 minus. Okay, 2 minus. Don't worry too much about the word 3 and 2 minus and 2 plus. You will know in form 4. But the way to identify that 2 should be noted. So I would like to show you another video to tell you how you can identify calcium carbonate. Remember to test.
Crush the solid sample of limestone into powder by using the mortar and pestle.
Now, mortar and pestle, what is that? Mortar and pestle is an instrument. Here, you may find it. This one is a mortar, and this one is a pestle. So you put the solid into it and then crush it, and they will turn the powder, turn it into powder. We continue.
Moisten a platinum wire or nichrome wire in a test tube of concentrated hydrochloric acid.
Now, what is that? What is that? What test are you going to have? Yes, that's right. It is flame test.
Heat it in the hottest part of the Bunsen flame until no characteristic colour is shown. After the cleaning, dip the wire into the concentrated hydrochloric acid and then into the crushed sample of limestone. Heat the powdery sample on the wire in the hottest part of the non-luminous flame. Observe the colour of the flame. Put 5 spatula measures of solid limestone into another test tube. Add 5 cubic centimetres of dilute hydrochloric acid to the test tube containing limestone. Quickly cover the test tube with a rubber stopper fitted with a bent delivery tube. Direct any gas given off into the test tube of lime water or bicarbonate indicator. What can you observe in the tube containing limestone and dilute acid? What can you observe in the test tube containing lime water?
So, do you know what we are going to talk about? Yes, that's right. We have got 2 tests. Now, first of all, for the test of a metal part, I use flame test. Okay, I use flame test. So you have to circle with flame test. So what we observe to the flame color, we give a brick red flame. So why? Because we have got calcium ion inside. It is brick red. Now it's easy, right? I don't want to mention too much of the procedures. You may refer to the previous chapter. The second one I would like to introduce to you is about the test for carbonate ions. Carbonate ions, what is so special? Carbonate ions react with what? Acid. So under circle the word dilute, acid, dilute, hydrochloric acid, 鹽酸. So no need to be concentrated, okay? Just dilute. Dilute hydrochloric acid is added to a sample. The sample dissolves, first of all. This is observation number one. There is effervescence. Observation number two. What is effervescence? Some colorless gas bubbles are formed. Okay, so and if of course, if there is colorless gas bubbles, I do not know whether or not it is carbon dioxide, right? So I need to check what the gas is. So how? I put it into the bubble it into the lime water, and the lime water, they will be turned from colorless to milky. So I know that the gas is carbon dioxide. So I would know it indirectly that the sample is a carbonate. Okay, so remember the test, the method, the observation, and the further test of the gas. Okay, so what is that? So equations, so you have to memorize the equations. Okay, so which is the calcium carbonate react with dilute hydrochloric acid to form carbon dioxide and water and calcium chloride. Now, somebody will find it quite difficult to comprehend, right? But if you know more about the chemical formula, so you may try to split into two, right? It seems like the reaction between the carbonate ion and hydrogen, yeah, hydrogen ion to form carbon dioxide and water. Leaving behind is just calcium and chloride. Okay, so you merge that two to form calcium chloride. Okay, so this is rather complicated, but don't worry, you may spend some time on memorizing it. I'm sure you can make it. Now, so you may find this setup. So for some instance, you are going to draw, okay, draw label setup. If you are asked about this question, you should have this concept in your mind. You have got a solid sample under test. I add dilute hydrochloric acid. Some gas come out. I know it's CO2, right? But you have to bubble it, bubble the gas into lime water. So what is mean by bubble the gas? Bubble is a verb. Okay. So just like you have a straw, you blow in the gas in the lime water. Okay. So that's why the delivery tube should be put inside the lime water. Okay. By doing so, you can do the bubbling. Okay. You may do the bubbling and wait for some time and see if the lime water turns milky. If the lime water is turns from colors to milky, the gas is carbon dioxide. So I know the solid is carbonate. Okay, so this is what you may know it about this test. So finally, shall we do the checkpoint now? The checkpoint. Oh yes, that's right. This is commonly asked in the exam. So put a Greek star here. So it will tell you a transformation of this. So take note of the arrow. Calcium carbonate, arrow to this, arrow to this. This one to have an arrow to this, and this one bubbles CO2, carbon dioxide, and we'll go back to this. So can you get to know what is X? Yes, that's right. Something react with carbon dioxide to turn milky. So what is that? It is lime water. Okay, lime water. LIMEWATER. So lime water. What is that in chemistry? We call that calcium hydroxide solution. Okay, calcium hydroxide solution. And you can answer either this one or this one. But remember, if I ask you for the chemical name, you have to answer this. Okay, but if I ask you to talk about the common name, You have to answer this. You cannot change the naming if I ask you something very, very specific, okay? This is chemical name, a proper name, calcium hydroxide solution. It is a common name, it seems like nickname. So it is lime water. Okay, you get the point. Yeah? So how about B? Suggest how again. Suggest how means you are going to do some experiment. You can carry out the following conversions and write down the word equations for the reactions involved. So for example, calcium carbonate to turn to calcium oxide. You talk about this one part 1. How? Yes, something is missing. You are going to heat the calcium carbonate strongly. Okay, so you are going to write down the word equation. So how will you write it down? This is calcium carbonate to form strong heat above the arrow to tell you what you're going to do to form calcium oxide plus something, right? So what is plus something? Now, you would, it's time to take a look on the name and try to guess. Calcium is here. Carbonate. Nate means oxygen is here. How about something is missing? Carbon, right? So it is carbon. It's not just carbon dioxide. Okay, you have get oxygen. So remember, calcium carbonate undergoes strong heating to form calcium oxide and carbon dioxide. 2. So this one is a strong heating. Okay, how about number 2? Calcium carbonate to form calcium chloride here. That should be here on the graph. Calcium carbonate to form calcium chloride. How? Yes, that's right. Now, because now you use the same tricks, right? Carbonate, chloride, right? Something is missing. I edit, I change the position, right? It seems I changed something. So what is that? Yes, that's right. I add what? I add dilute hydrochloric acid, okay, to calcium carbonate. Okay. Sorry to write it down the word. I write it down in a more proper handwriting, right? Calcium carbonate. So what is the chemical equation? So write down calcium carbonate reacts with hydrochloric acid to form calcium chloride, carbon dioxide, and water. So how you memorize such as I told you before, right? Calcium react with chlorine, okay? So we call that calcium chloride to form calcium chloride. And second is what? So the remaining, what is that? The remaining, it is here, right? Carbonate hydro means hydrogen to form carbon dioxide and water. How will you know that? Carbonate is C is O. Hydro means hydrogen. So carbon dioxide CO2, water is H2O. I use this which help me understand and memorize more. Okay. So how about the third one? Calcium oxide turn to X. How? How? Calcium oxide plus turn to X, which means the third one here. How? Yes, that's right. So again, as said before, I mark it here. It is calcium hydroxide solution. Okay, this is calcium hydroxide solution. So you may imagine calcium oxide is CaNO, right? This one is Ca, hydro is H, oxide is O, right? What is missing? Yes, that's right, hydrogen. But do we need to add hydrogen to it? No. Any common chemical which has hydrogen in the world? Yes, water. Can you get a point? So this is the way I memorize it. Add water. Yes, that is the answer, right? Add water to calcium oxide. But wait a minute, Mr. Chin, I add water to calcium oxide. It's not lime water, right? It's not lime water. Yes, it depends on how much water has been added. I need one more word. What is that? Yes, excess. Large amount, okay? Etc. You may need to tell me a very large amount of water to calcium oxide. To calcium oxide, what will form? Okay, stir the solution and then filter. Okay, and then filter. So you may get the filtrate. Okay, the filtrate being lime water. Filtrate. How would you spell filtrate? Filtrate. Okay, so what is the word equation? Calcium oxide plus water to form calcium hydroxide, okay, solution actually. Okay, can you get a point? So this is for question 1. The final questions before we end up the lecture today. 2 different white powders. They are thought to be calcium carbonate and calcium hydroxide. Wow, once again. Yes, that's right. At the equation, the question talk about distinguish, right? Describe a test to show that both powder they are calcium compound. So can you please underline the term both, which means all the 2 carbon compounds. So what are they in common? Calcium. They will have calcium ion. Okay. So how we prove that they are calcium compound? Yes, I need to do a test, right? Flame test. So what will be observation? Both compound, they will give the same observation, which is, what is the flame color? It is bright red flame. Okay, so this is the I would like to count the marks like this way. 2 marks, right? 1 mark flame test, 2nd mark bright red flame. The last, very last part. Describe a test to find out the which of powder is calcium carbonate. How? Yes, odd one now, right? They are going to test one thing in which one of the chemical they will give a very special observation, while the others would not. How? Yes, try. How about I add right? Yes, some of you may think that, how about adding acid to it? Yes. Calcium hydroxide, sorry, I add dilute hydrochloric acid hydrochloric to each of the sample separately, which means respectively or one by one, right? So what will be expected for this part? First of all, colorless gas bubbles are given out. The sample is calcium carbonate. Okay, the reactor sample is calcium carbonate. If not, what does it mean by if not? If there is no formation of gas bubbles, the sample is calcium hydroxide. How you know, Mr. Chin? Is there any chemical reactions between calcium hydroxide and acid? Yes, that's right. So what is the observations? What will the observation? Why come there is no color gas, right? What is that? Well, I may use the same idea, right, as before. I would like to merge calcium with hydrochloride, right? Hydrochloride, correct. So you may get calcium chloride. You've got calcium chloride, right? How about the next one? How about the next one? So you may have this hydroxide, O and X, right? And hydro means H. I merge that two, what will be formed? Yes, that's right, water. So do you know that we don't have any CO2? Why? Yeah, because that calcium compound, do they have any carbon? No. How about the acid? Do they have any carbon? No. So how come? Right? Of course, no carbon dioxide because no carbon. So by doing so, I do hope it will help you understand more about the equation. Okay, the equation, which is which. So I would just like to stop here and hope you guys enjoy this chapter, rocks and minerals. You may find that the most important part for in this chapter is to memorize this limestone cycle. Okay, I put so many stars here. And second is the way to test for the calcium carbonate. We have got to test. If you want to test for the calcium ion, you use flame test, break flame. Second is about the test for the carbonate ions. I would like to add dilute hydrochloric acid to it and wait until you may see some colorless gas bubbles, and you have to check the colorless gas bubbles to see if it is carbon dioxide. How? I bubble the gas into lime water and try to see if it turns from colorless to milky. If that is the case, you'll be quite sure that the sample is calcium carbonate. I would like to stop here. Thanks for watching.